All right. So if you worked on any projects with me, or I've talked to like at all, I've probably told you how much I like Tailscale. It was told to me from one of our alumni a while back, and it's one of the best things ever. So this is the VPN solution that you didn't know you needed. So, who am I? Is up there, and oh, there we go. Who am I? I'm Drew. I'm a fourth year. I'm from Massachusetts. I'm gonna be working at SRA when I graduate in May on their advisory red team. I work for Tech Crew. I like hockey. There's a hockey game tonight and tomorrow. It's home. I'm the red team chief. I'm on ops. I do CCDC, and retired in for lead. So VPNs. Let's just start with the basics. What is a VPN? So a VPN, or virtual private network, is a secure or service that creates a secure encrypted connection over the internet for data to flow through, for your data to flow through. And what this does, the key purpose of this really is to encrypt your internet traffic, to hide it from your ISP. All the traffic will be going to the VPN instead of to your ISP, and then from there onward. So they just see it going to the VPN provider. It also lets you access private networks sometimes, depending on what you have set up. And you can also change your egress IP address, which is pretty cool. Also, sometimes, depending on what VPN you have set up. So some current solutions for this right now are OpenVPN. We use that a lot here for like competitions, or just like pfSense uses OpenVPN too under the hood for doing VPNs there. WireGuard's a good solution. TwinGate and Tailscale are good mesh VPN solutions. And there's commercial VPNs like Proton, NordVPN, Surfshark, like a bunch more like that, which you can pay for, and they'll change your egress IP address like we just talked about. But they won't give you that access to private networks type of thing like some other VPNs do. There's also a lot more than just that, but that's just a quick overview. And as you can see in this little diagram right here, so with the VPN, your traffic on your device gets sent and converted to your VPN provider. That goes through your ISP, comes out at your VPN provider, then to the internet. Versus if you didn't have a VPN, it would all go through your ISP. So they see everything. So how do we use VPNs in RITSEC? Well, there's two main ways that I thought of when I was creating this presentation. There's probably a few more as well, but these were the two main ones that I was thinking of. The main one is for competitions. So for black team and red team having access to the competition networks, those are all private networks, and we aren't on that network when we're on the RIT network. So we access a VPN, which brings us into the internal network. We use what's called a split tunnel VPN, which is this thing down the bottom here. So all of your regular web traffic will go out to the internet like it normally does, but all of your local traffic to IPs that we define will go into the VPN tunnel and out into the network that we want. So for competitions, we'll say everything going to 10.0.0.0/8. So the entire 10 dot address will go through the VPN. Same thing for like 192 and 172.16 and all those too. So all that traffic will go through our VPN, and we can talk to the competition machines, deploy stuff to them, attack them if we're on red team, stuff like that. And then for ops, for accessing the stack, because the stack is behind on a private network as well. So yeah, I'm sure Stella had a lot of experience using that VPN, unfortunately. But yeah, that's how we use them so far. These are just some of the types of VPNs too. So there's remote access VPNs. This is what people will use on like their work laptops, where they'll just like connect to the VPN. All their traffic will go through their work network, or maybe they'll reach an internal resource on their work network. That's just kind of what that's for. There's site-to-site VPNs, which connect entire networks. So this is good if you have like two companies that need their networks connected. Maybe it's like a subsidiary that was just purchased. You can connect them that way with the site-to-site VPN. And then there's peer-to-peer, which is direct communication without a central server. So clients will just talk to each other instead of having to go through a centralized server for the VPN. Using that peer-to-peer type of thing, there's a thing called a mesh VPN, or it's a type of VPN called a mesh VPN. And it uses peer-to-peer networks where devices directly connect to each other like we just talked about. And there's no centralized server because of the peer-to-peer, and each device on that mesh is a node. So as you can see over here in the little diagram, every single device can talk to every other device because they're all in that VPN mesh. They're all on the same network together, and they talk to each other directly. This is what Tailscale uses. Some key features of this: there's no bottleneck since there's no centralized server. There's less latency because they're all connected directly as well, and it's easily scalable. You can just spin up another node, and they can all connect to each other, which is pretty cool. But thinking back to our regular VPN solutions, there's a big problem with them. And that's that most of those private VPNs are a hassle to set up because they're very annoying. They take a long time. They require a public IP address and an open port. And the solution for that is you can just like, cross your fingers that your machine isn't behind a net. But that's not really a solution. That's just kind of like another problem. So we'll move that back to problem. So we have the problem that our machine is behind a NAT. So how do we get a VPN there? Well, your solution there is Tailscale. 1,200,000. Anyone know what this number means? Big numbers catch your audience's attention. So Tailscale. It's a mesh VPN solution that's built on WireGuard. It focuses on simplicity, security, and usability. It's a beautiful thing. There's lots of pros to using Tailscale. It's very, very easy to set up. I cannot emphasize that one enough. Very easy to set up, which means that joining new devices to the network is also very easy. It's all peer-to-peer connections like we just talked about. It's all a big mesh network and uses NAT traversal, so you don't need a public IP address. You just have Tailscale. They have a whole article on how they actually do NAT traversal, and it's really, really good. This is one of the diagrams from it. Basically, they use the fact that firewalls will allow incoming connections if you send out a packet on the same like destination and port. If it's coming back in, it doesn't have to be related as long as it's like coming from the same source. It's a crazy thing. You can just Google like Tailscale NAT traversal, and they'll talk about how they do it. It's really cool. Some basic terminology for Tailscale. So we have nodes, which are the first things. Nodes are any devices that is connected to your Tailscale network, which they call a tailnet, which I actually put telnet, but it's supposed to be tailnet, so let's call it a tailnet. And a tailnet is a private network created and managed by a Tailscale that your nodes will join to. Then you have the admin console, which is on their website pretty much. It's how you manage your entire tailnet. Then there's Magic DNS, which is one of their features, which is built-in DNS for devices on your tailnet. You can also set like DNS servers for your tailnet. It's like when you install Tailscale on one of your devices, you can tell it which DNS server it should actually point to. And then it uses WireGuard under the hood, which is, the VPN protocol Tailscale uses. So setting it up is really, really simple. As I talked about earlier, you just install and log into Tailscale on one of your devices. Maybe it's like a phone, laptop, or computer. And then you do it again on another device, another phone, laptop, or computer. And then now they're connected. It's actually that simple. So I actually did it and took screenshots. So we'll quickly go through those. So first thing I did was I set up a Tailscale demo box on DigitalOcean. And then I went to their website and just made an account. I logged in with a private Gmail account. Don't log in with RIT, by the way, because you're all going to get joined to the RIT tailnet, and you can see every other device on RIT's tailnet. So yeah, don't do that. But log in with Gmail, you're good to go there, but don't do RIT. Or GitHub, that's pretty cool too. So I did that, and it just tells you, hey, run this little script over here, and it'll be cool. So I ran it over here, and then it was like, hey, if you want to authenticate, just click this link. And then I went to that link and clicked approve, and it was like, okay, cool, you're now on your tailnet. And then I did it again on an old RITSEC machine. And then it was like, hey, cool, you're done. You can now connect anywhere. So now we have two devices down here. We have Propaganda Team 12 Cold Conflict from IRSec back in, November or something like that. And then my new Tailscale demo box. It gave them both 100.x addresses. That's what Tailscale uses for its like internal IP range. You can also use Magic DNS like we just talked about and just ping like Tailscale demo or ping Propaganda Team 12 Cold Conflict. It shows you the version of the agent that's actually running. It shows you if it's ever like when it was last seen. If the device goes offline or leaves the tailnet, it'll show you when it was like last detected there. You can do so much more with this, so we'll get into that. One of the big features with this is that public and private devices can connect to each other. So I'm on the public box right now, Tailscale demo, which is the DigitalOcean machine. And say I wanted to reach that propaganda machine, which is behind a router, which is on like the stack right there. Then it's behind another pfSense router because it's on like another internal network of that. We can just reach that directly since they're both joined to the tailnet. So this is just pulling a simple web request onto propaganda, and it shows you that it can actually reach it. So that's very cool. Another cool thing you can do with it is you can set up these things like called routes, and you can advertise subnets everywhere. So this is something that I actually use on the stack to like develop things and work on cool red team tools and like some class products and stuff like that. So for example, when I run Tailscale on a box on the stack, the first thing I do is just make a network like I have over here. I connect it to a router, and that goes out to the WAN. And then you can just join a couple boxes to that. So over here, which is the screenshot I just showed you, I just ran sudo Tailscale up, accept routes, which tells it, hey, if anyone else is sharing a route, let me use it. Advertise exit node, which we'll get into in a little bit, and then advertise routes. So I advertise 10.1.1.0/24. So that means that on Tailscale, I can go hit approve on that route, and any devices that are accepting routes with that little argument accept routes over there will be able to just talk to any devices on 10.1.1.0 directly through Tailscale. Very, very cool feature. It allows something like this over here. I have my Mac joined, and I can reach 2 machines on that network right there just by pinging them directly. I don't even have to like go to OpenVPN, turn on the VPN or anything. I just leave Tailscale running, and it just connects me directly to the network, which is fantastic and very convenient. Now, back in this last screenshot again, we have TAC advertise exit node. So now we'll get into that really quick. So this is me on the Tailscale demo box again, which is spun up on DigitalOcean, if you remember from a little while ago. So I ran the little flag of advertise exit node, and I checked the box that says use as exit node. And then now if I go back to my private machine, which is the propaganda machine, I can tell it to set the exit node to, and then the IP address of that one machine that we wanted to use, which is the Tailscale demo box, which is the 100 dot whatever. So I tell it use this as the exit node, and it has to allow LAN access. That way we can still access things locally. Otherwise we'll route everything, including LAN traffic, through the exit node, which we don't really want. So we do that. And then when you pull IP info, which just tells you your IP address, it's a website that does that and returns it in JSON. We see that our IP address is coming out as DigitalOcean, which is a 159 address. And then we can turn it off by just doing set and leaving it blank. And now we come right back out from RIT. And that's the IP address from the stack, the core router for the competition. Another cool feature of Tailscale that I actually found out about very recently is something called the Tailscale funnel. Funnels are very, very cool. So for example, this is something we can do on just a private machine without a public IP address, once again. And we can advertise ports to non-tailnet joined devices. So for example, we spin up a little Python web server in the top screen right there. So now it's listening on port 8000. We are on the propaganda machine, so we have a private IP address. We are double natted behind a couple routers. And we just run another thing on the same machine saying Tailscale funnel 8000. And now any device can reach out to this HTTPS link over here, and it will forward it to port 8000 on that private machine there. So this means if you want to share out a random port for testing with one of your friends or something like that, or one of your classmates, you can just run this on one of your machines and say, hey, yeah, visit this link, and here is this public thing. That's very cool. Here's a quick example of how it worked. So since this is sharing out just HTTP web server, this is the home directory right there. So very, very cool. You can also share out nodes individually. So like we have our devices on that list in our tailnet. We can actually just share them out using one of these right here. You can share it to someone's email or just copy a link. This is something that we did back in CSEC 3.10. We shared out one device as on our tailnet, and we could all access that one device and access our entire network that we were all testing on. So just for some more cool features, there's something called Taildrop, which is like AirDrop on like the iPhones, but through Tailscale for machines on your tailnet. So you can just like share files between all of them. There's Tailscale SSH, which replaces your SSH server with like a Tailscale version type of it, and it doesn't use keys. It just knows, oh, if you're on the tailnet, we'll check the ACLs and see if this is allowed. There's also Tailscale SSH console, which means you can SSH into one of your nodes from the web console. I haven't had a use for that yet, but I mean, it could be helpful at some point. And then you can configure ACLs, access control stuff, to like restrict network access. You can restrict exit nodes. You can do a bunch of different things like that. This is a quick common use case for most people. This is probably one of the biggest things of using Tailscale. So say you're like AB, right? And you live over in California. But you're up here at school in Rochester and you want to watch Netflix. So you pull up Netflix and all of a sudden it's like, nah, you can't do that because you're not home. Well, but then like you remember, hold on, wait a second. Back at home, I got a Raspberry Pi running. It's running Tailscale. Okay, it's quite simple. You just go on, change your exit node, and now you're watching Netflix. Okay, it's quite simple. There's also some more uses, especially for like being at RIT. So some group projects where you might have to like share infrastructure, like I was just talking about, endpoint engineering, the CSEC 310 class. That's a great use for it. Web app, if you want to spin up some private machines, you can share those out with other people in your group. And CDT, maybe if you want to like talk to the competition network, it's also very easy because you can run things from your local machine. Or individual projects, like in penetration testing, Stackable has you spin up like this infrastructure, and I just drop Tailscale on it, and then I could just hop into my Kali box and then do the entire thing all through SSH, which is like so much more convenient than VNC in my opinion. Network services and sysadmin, all those classes are good for it too because you use like VMs in places. Or personal projects where you just want your own private network. Like I have the one set up on the stack right now. You just create the network, create the router, and then you can just join devices to the network. Or maybe a private VPN, spin up a DigitalOcean box, drop Tailscale on it, tell it, hey, you can use this as an exit node. And that's cool. Or maybe Raspberry Pi at home, like we just talked about. You can always be on your home network. Tailscale is the GOAT. Someone famous said that, probably. It's awesome. Here's some other people who love it. And yeah, thanks. Anyone have any questions? Yeah. Yeah. The question was how did I use it for penetration testing? So Stackpole has you spin up like a few boxes. There's a Kali box. There's a few Windows boxes. There's a few Windows servers, stuff like that. I dropped Tailscale on the Kali box, and then I could just SSH into the Kali box whenever the infrastructure was put up. And then since it's so much easier just to use SSH, in my opinion, you can do stuff like that. You can even like SSH port forward or like share out that entire subnet. That way you can just access everything from your host. So you can RDP into machines instead of like using the VNC console, which I hate VNC so much. So, and you can copy paste, yeah. Yes. So for Tailscale to work, the machines need to be online. So RList, you have to go on and just click like start deployment, and then you can close out of it and forget about it. Then you can just stick with Tailscale for everything else. So yeah, what's up, Scylla? The question was, why would you use Tailscale if you could deploy IPv6 everywhere? Are there any more questions? Yeah. Kyle asked, did the big number catch your attention? Raise your hand if it caught your attention. Beautiful. The big number caught a lot of attention. Yeah. Yeah. Ooh, the question was, how can you automate this process? Do you mean like setting up Tailscale or? Yes. True. So with Tailscale, you only have to drop it on one machine on that network. So like I just did with that propaganda machine in there, that's on a team subnet right there. So you just run Tailscale on that thing, and then you share out like advertise routes, advertise subnets, and you advertise all the subnets on the network, and everything is accessible now. So you only have to run it on one machine. That's what I use it on for like for CDT. It was so easy. I just like log into the team and then advertise everything else, and then I can access everything. So that's the easy way to automate it. You can also like write Ansible just to like run that one command. And you can use tags through the ACLs on Tailscale and say like, oh, if it has tags exit node or something like that, then it can automatically approve it as an exit node, or automatically approve routes or something like that. So there is possibility in automating it. Yeah, Kyle. Ooh, how easy is it to spot in your logs? If you just run like a process list, you'll see Tailscale running. And if you run like IPA or ifconfig or something like that, it adds another network adapter with that 100 address. So there are a lot of like telltale scale signs that it's running. Yes, Will.
Tailscale might be cool, but what's the least efficient way to send data between a public and private network?
A RITSEC USB.
Or it's like USB